Hello, everyone. Can you guys hear me? No, I'm in class. Okay, thank you for responding. I'm so sorry for being online today. Um, thank you so much for being here. um, and also I'm sorry for being late. Um, I was having a hard time connecting with the internet here. Thank you, Ahmed. Yeah. So I think it's stomach virus which is going on. So I was vomiting and everything. Um, Today I feel a little better. So I'll let you know Wednesday. Should we have online or in-person class? So not Wednesday, Tuesday night. Thank you so much for being so understanding. Don't forget to do your homework by tonight. Your first homework is due tonight midnight. By tonight midnight. I seen many of you already submitted. So only a few of you did not submit yet. So please do so. And today we will be finishing 1.2. So we are almost done with 1.2. I'll just do 2 questions today. And then the rest you'll do new homework for practice. So that means next week, Monday midnight, you're going to have 1.2 homework. And 1.3, I don't think we'll be able to finish it this week. So most likely its homework will be due next week, next week, Monday. Thank you everyone for your kind words. Thank you so much. Any question before we start? No question. So we learned about row echelon form and reduced row echelon form. And in our last class, we did one example of this. So if you use, thank you, Rakmanjam. I didn't know you're Muslim. Wow, great. Um, so yeah, so if you stop at row echelon form, we call it Gauss elimination, the process. But if you simplify all the way to reduce row echelon form, then the process is called Gauss-Jordan elimination. But they're the same process, same everything. One step in the middle and one step at the end. So in our last class, we had a 3 by 3 coefficient matrix and 1 by 3, no, 3 by 1 constant matrix. And we applied row echelon form on it. And at the end, we were able to do reduced row echelon form. And we realized that we had infinite solution. Even though we have infinite solution, you cannot stop saying we have infinite solution. We still have to figure out the equation for each variable. What is x1, what is x2, what is x3? And we have to indicate which one is our free variable, means it doesn't depend on anything. You can plug in any number on that. And which one is leading variable. Leading variable depends on free variable. So for infinite solution, we have to write the leading variables in terms of free variables. So we did that x1, x2, x3. We find out that x3 is itself, it's free, and x2 and x1 depends on x3. Now, today we're going to do very similar things. Here we have 2 variables but 3 equations. So let's see what type of solution we are going to get this time. And how I need to do this type of question you have to be very careful. One tiny mistake ruin everything. So when you do them, try to concentrate on your algebra. And in the exam, you're going to get only one question of reduced echelon form. So our first step is write our system of equations into augmented matrix. So we have 1, -2, 3, 2, 1, 1, -5, 8, 4. And then we put a bar between coefficient matrix and the constant matrix. If you don't want to put the bar, it's fine, as long as you remember that the last column is the constant matrix. Our goal is to convert this matrix into 1, 0, 0, 1, and then probably 0, 0. So if you want to get unique solution, we want the last row to be 0, 0, 0, means this is not important. And we want some constant here and some constant there. This is our goal, to have unique solution. We always want to have unique solution. But not always we get unique solution. Sometimes we get infinite, sometimes we get no solution, and sometimes we get infinite solution. So if you compare what we have and what we want, our first term is 1 here, and we want first term 1, so we are safe. So we don't have to worry about the first column, first row. Then here we have 2, but we want 0 here. So goal is to convert 2 to 0. That means we are going to change our row 2. So the new row 2 we indicate with the row 2 star. And we want to see what can we do so that we can get 0 instead of 2. Riot is giving us our answer, 2 row 1 minus row 2. We can do that, or we can do row 2 minus 2 row 1. If you do this way, then later we are going to find decomposition of the matrix. The decomposition of the matrix always requires whatever you are changing, that row has to be written first. So if you have this habit from the beginning, when you do decomposition of your matrix, you're not going to mess up your algebra. So they're the same thing, but it just changed sign a little bit differently. So we are changing row 2. So row 2. So let's write down our row 2 is 2, 1, 1. And we have row 1, this entire row 1, we are multiplying by -2. That means 1 times -2 is -2. -2 times -2 is +4. And 3 times -2 is -6. So when you combine them, we get 0. 4 and 1 gives us 5. 1 minus 6 gives us -5. So this is our new row 2. At the same time, we want this -5 to be 0, because this is what we have here. So we can do the same thing. We are changing row 3 this time. So row 3 star means the new row 3 is the current row 3. And if you multiply your row 1 by +5, then 5 times 1 and 5 times -1. So 5 times 1 is 5. If you add -5, you get 0. So row 3 is -5, 8, 4. And if you multiply this entire row 1 by 5, we get 5 times 1, 5. 5 times -2, 10. And 5 times 3, 15. So when you combine, this is 4. This becomes 0. 8 minus 10 is -2. And 4 plus 15 is 19. So this is our new row 3. So we have 1, -2, 3. We did not change anything on the first row. Our new row 2 is 0, 5, negative 5. And our new row 3 is 0, negative 2, 19. Any questions so far from anyone? Is any of you feeling lost yet?
Just have one question.
Go ahead.
So every single time, we apply that rule where we switch row 2 with row 1, right? Just to,
Right.
or
So you can do row 2 or row 3, doesn't matter here.
okay,
But when you're going to do the decomposition have a strict rule. Whatever row you are changing, you have to use that row. So for example, here, this is row 2, column 1. So you have row 2, column 1. The rule says you can do row 2 and then row 1. You can apply only these two. This is 2 for decomposition. So if you have the habit from the beginning to get ready for decomposition, when you'll do the decomposition, then you'll see like all the rules will automatically stay in your head. But you can,
okay,
for now, you can apply any row, any column. It's fine. Not column, sorry. Any row you can apply. You can
okay.
use any row.
Thank you.
No problem. So if you compare what you want, you can see that you already have what you want in the first row. Sorry, in the first column. So you're happy. And now we go to second column. The second column, we always should start with the middle term, not the middle, the diagonal. So the diagonal, we want 1, but we have 5. This will be easy, right? How can we convert 5 into 1? So we are going to change row 2. Divided by 5. So current row 2 divided by 5. And let's change 1 at a time. So we have, insert a page. Okay, so we have the first row without any change. We have 1, 2, 3, 1, negative 2, 3, and the new second row is 0, 1, negative 1, and then we have 0, negative 2, 19. So we have our diagonal as we want. Now, if you compare, we want 0 below the diagonal. So that means this negative 2, we want it to be 0. So since we are on second column, we can the only thing we can use is the second row. So when you change row 3, we need the help of row 2. So row 3 is current row 3 plus 2 times row 2. If you do that, let's do the math on the side. We have row 3 is 0, negative 2, 19. And 2 times row 2 is 0. 2 times 1 is 2. 2 times negative 2 is negative 2. So 0, 0, 17. So we have 1, negative 2, 3, 0, 1, negative 1. And the new row 3 is 0, 0, 17. So we don't need to go any further. We already know what's the solution here. Who can tell me what's the solution here? No solution. Why, Rayat? How do you know?
It's too much to type, but because 0 can never equal 17, it's impossible.
Exactly.
Three.
How can 0 plus 0 be 17? So this information is telling us, hey, stop. It has no solution. So basically, we wasted our time. The system of equations we have, they never cross one another. We get solution only when they cross once. Here, all three lines, probably they're parallel. They're never going to cross one another. So any question on any other step? Any comments so far? Now we are going to do the last example for this section. Oops. Would you like to try it on your own and then see the result, or do you want me to do it just like the last one? What do you think? Any suggestion from anyone? Maybe you can try on your own. I'll give you 10 minutes. And then once you try on your own, you'll see like what type of problem you face. And then you can ask me a question. Is it okay, guys?
Yeah.
Okay, then 10 minutes. Try on your own. And then after 10 minutes, we're going to do it together. And I'm here, so let me know anytime you need any help. And if you have class in the West building, I see an email. It says from 3 to 8 today, there will be no heat in our West building. So don't be afraid if you have no heat in your classroom. It's just temporary. And while you're doing your work, I should take your attendance from the participant list. So I'm taking attendance, okay? You can unmute yourself and then say you're here. Ahmed,
Yes, here.
Christelle,
Here.
and Christian.
Here.
Danielle.
Here. Here.
Thank you. Eric.
Here.
Florence.
Here.
Gashan.
Here.
Julian. Oh, sorry, I went too far. Halil.
Here.
Jack. Jackie,
I'm here.
good. Imran,
Here.
Jonathan, Juan, Julian, Julian, can you hear me?
Yeah, I'm here.
Okay. Karma,
Here.
Kate,
Here.
yeah. Kathy, okay, let me scroll down. Main,
Here.
Matthew,
Here.
sorry, Man. You told me to call you Man. Melissa,
Here.
Muhammad,
Here.
Muntaha,
Here.
Omar.
Here. Here.
Omar, did you sign in from 2 account or I have 2 Omar? Which one?
Omar D.
Omar C. Also, you're Omar D. Okay.
I'm
So I have
here.
2 Omar. So Omar D is here. How about Omar C? Here. Okay. Prabhat,
I'm here.
Rakmanjan,
Here.
Rayat,
Here.
Sadia,
Here.
Saraya,
Here.
Saima,
Here.
Stephanie,
Here.
and Valerie.
Here.
Thank you. So all 32 of you are here. So I'm missing 3. Okay, not bad. Thank you so much, everyone, for being here. Do you guys have any complaint about do you guys dislike online classes? Do any of you dislike online classes? Don't be afraid, I'm just asking. There is no penalty, no punishment. No? Me too, Stephanie. I love online classes. Actually, yeah, like I said before, my physical body is really weak. I get sick really fast. So most of the time, not most of the time, many days I have to hold class online. Not only for with you guys, like in previous semesters, it happened a lot. And especially if I get my cough, it's really bad. So that time I prefer having online classes because people hate someone when someone cough. And it makes me sad. So thank you so much everyone for being understanding and for loving online classes. Even if you don't like online classes, don't worry, when we meet in person again, all the questions you have, try to have them write down on paper so you can ask me when we meet in person. Okay? So no complaint. Plus we have office hours, so anytime we don't understand anything and we have in-person classes, feel free to talk to me in the office hours. I'll help you with everything you did not understand or do not understand in any of our online classes. So are you ready? Did you guys try the next question? Okay, Rahmanjan. Thank you for letting me know. So who would like to help me with this one? The next question. At least writing down the augmented matrix is easy, right? So volunteer for augmented matrix.
I can do it.
Okay, tell me please.
So the first row will be -1, 2, -1, bar 2. Second row will be -2, 2, 1, and 4. And third row will be 3, 2, 2, and 5. Last row is -3, 8, 5, and 17.
Perfect. So our goal is to write this into 1, 0, 0, 0, 1, 0, 0, 0, 1. And since we have 3 variables but 4 rows, so we want the last entire row to be 0 for unique solution. So this could be any number, this could be any number, this could be any number. But this is the format we want. So who would like to help me with the first column, first row, first column? We have -1, but we want +1. So we need to change our row 1. What do you have to do?
And multiply by -1.
-1, row 1. And then we have -2 here, but we have 0 here. You can do it in 2 steps or you can do everything in 1 step. It's up to you. At least you need to write down the formula. Even if you don't show the work, you need to write down the formula, like which operation you are using. You must write down your operation. So we want -2 to be 0 because we have 0 here. So we need to change our row 2. So it will be what? Row 2 and then?
Would it be row 2 minus 2 times row 1?
Perfect. So let's do the math here. We have row 2 is -2 to 1, 4. And if you multiply this entire row by -2, we get -2 times -1 is +2. -2 times 2 is -4. -2 times -1 is +2. -2 times 2 is -4. So when you combine, we get 0, -2, 3, 0. Next, we have 3 here, but we want 0 here. So convert 3 into 0. So I need to change row 3. So it's current row 3 and then addition or subtraction, whatever. Who can help me with this one? Anyone? We want to convert 3 into 0. Add row 3. Okay, if you want, you can do that. We can do row 3. Oh, we're changing row 3. So what do you have to add? Which row? Row 1. We can add row 1, but this time we have -1 and here 3. So you have to cancel them out. We need to multiply row 1 by 3. If you multiply row 1 by 3 and then add with row 3, we are going to get 0. So let's do the math here. We have row 3 is 3, 2, 2, 5. It looks like 25. It's not 25, it's 2, 5. 2, 5. And if you multiply this entire first row by 3, we get 3 times -1, -3. 3 times 2 is 6. 3 times -1 is -3. And 3 times 2 is 6. So when you combine, we get 0, 8, -1, and 11. So we are happy we have 0 in the first column. Sorry, in the first column. And now the last thing, we have 3 here, -3 here, but we want to change this -3 into 0. So we are changing row 4. And this time it's easy. If you just add row 3 and row 4, we get 0. So row 4 is current row 4 plus row 3. So if you do that, we get 3 minus 3 is 0. 2 plus 8 is 10. 2 plus 5 is 7. And 5 plus 17 is 22. Right? If you add these two, 3 minus 3 is 0. 2 plus 8, 10. 5 plus 2, 7. 7 plus 5, 22. So let's insert. Let's write down our new matrix. We have the first one. Let me close my chat box. We are multiplying the first row by -1. So we get +1, -2, +1, -2. And then the second new row is 0, -2, 3, 0. New third row is 0, 8, -1, 11. And the new fourth row is 0, 10, 7, 22. So we got the entire first column as we wanted. So we are happy. That means next we are going to go to the diagonal. Means this one. This entry we want 1, but currently we have -2. So what can you do so that -2 will turn into 1? Any idea? We are changing row 2. So what can you do? Multiply by -2. So you not multiply, divide. If you divide this by -2, it will turn into 1. So take row 2 divided by -2. Our -2 will turn into 1. So it's a simple one. Next, we want this 8 to be 0. So we are changing row 3. So we take current row 3. And then which row you need the help from? Row 2. So what you can do with row 2? You need to multiply your entire row 2 by what? So we have 0, 8, -1, 11. Multiply by 4. Perfect. You need to multiply this entire thing by 4. So you get 4 plus 4 row 2. So 4 times 0 is 0. 4 times -2 is -8. 4 times 3 is 12. And 4 times 0 is 0. When you add, you get 0, 0, 11, 11. and we are happy because we have 0 in the second position. Then we look at 10. We don't want 10, we want 0. So we need to change row 4. So current row 4, and we can do the same thing. You can get the help of row 2, but this time you need to multiply by 5. If you multiply this entire thing by 5 and add with row 2, look what happens. Our current row 4 is, let me do it here, 0, 10, 7, 22. If you multiply row 2 by 5, we get 5 times 0 is 0. 5 times negative 2 is negative 10. 5 times 3 is 15, and 5 times 0 is 0. When you add, you get 0, 0, 22, 22. So this is our new row 4. So it did not change row 1. So 1, negative 2, 1, negative 2. We divided row 2 by negative 2. So 0, 1, negative 3 half, and 0. Our row 3 is 0, 0, 11, 11. And our row 4 is 0, 0, 22, 22. We wanted to have 0, 1, 0, 0, and we have 1, 0, 0. So we are happy, but if you want, you can also change this negative 2. You can change this negative 2 into 0. You don't have to if you use row echelon form, but you must if you do reduced row echelon form. So we can change negative 2 into 0 because we have 0 here and we have 1 here. So it's doable. Anytime something is doable, it's better to do it. But you don't have to, it's just better to do it. So if you change row 1, our new row 1 will be current row 1. And we can do 2 times row 2. So plus 2 times row 2. So what happens now? Let me do the math here. We have 1, negative 2, 1, negative 2. If you multiply the entire, let me change this 2 from here to here. If you multiply the entire row 2 by 2, we get 2 times 0 is 0. 2 times 1 is 2. 2 times 3 half. So 2 and 2 cancel out. You get, oh, come on. Sorry, I have to restart my Word. My ink is not inking anymore. So let me save this. Wow. Save. No. So let me save. Come on. Yeah. Sorry about this, guys. Okay, so if you multiply the second entire row by 2, we get 2 times 0 is 0, 2 times 1 is -2. Oh, sorry, 2 times 1 is 2. 2 times 3 halves, so 2 and 2 cancel out. We get -3, and 0 times 2 is 0. So when we add, we get 1, 0, -2, -2. If you want, you can write this down. So we have our first new row is 1, 0, -2, -2. And then we have 0, 1, -3 half 0. We don't need to change anything here. And then we have 0, 0, 11, 11, 0, 0, 22, 22. Or maybe we can just change it here. We don't need the help of any other row. This 11, if you observe the diagonal, our next diagonal is here. So we want this diagonal entry to be 1. So this is our next diagonal entry. We want this 11 to be 1. Divided by 11. Perfect. So this is a simple case. Our new row 3 is current row 3 divided by 11. And we want this 22 to be 0. So here below the diagonal, we want 0. No, diagonal. Which one? Yeah. Below the diagonal, we want 0. So this is our constant. So we need to change row 4. So new row 4 will be current row 4 minus, you can get the help of row 3. If you multiply row 3 by 2, -2, so -2 row 3. Then we get -2 times 11 is -22. So let's do this math here. Our current row 4 is 0, 0, 22, 22. And we got the help from row 3. We multiplied row 3 by -2. So 0, 0, -22, -22. When you add, everything becomes 0. Guess what, Rahmanjan? You're going to have this in the exam. Not only in this exam, in the final exam also. The matrix algebra, one of the most important concepts in matrix algebra or linear algebra is this thing, Gauss elimination or Gauss-Jordan elimination. Yep. I know it's a lot, so in the exam, I'll try to give you something that is easily reducible. But what I feel easy may not be easy to you if you don't practice, guys. So that's why the homework, you may feel like homework is a lot, but actually this homework is to help you. Later, I'm going to give less amount of questions, but in this homework, we are going to do a little bit more homework questions. No open book, sorry. Even if I give you open book, it doesn't help you. Like, it will not gonna help you. You need to know all these rules, not rules, like the trick. If you want to cancel one number, which other number you can get the help from? You just have to figure that out. So please do the homework seriously. Don't copy from internet. You can check your work, check your solution from internet, but try to do it on your own because this definitely will be in the exam. also in the final exam. So you need to know this. Also, later when you're going to do programming, all of you are CSA student, right? Computer science or computer information. So you need to do programming. When you do programming, you need to write down all these steps in your coding so that computer can code correctly. Okay, so all these steps are really important. That's why you cannot just skip this. If you are going to work with computer science or engineering, you need to apply this later. So divide third row by 11, going to give you 0, 0, 1, 1. And the last row we just found is entirely 0. Since the last row is 0, so you're going to ignore that. And now if you want, you can change these two. But if you don't want, you can just skip them. We are going to do back substitution. I prefer back substitution because it's too much to keep doing all this math. So in the back substitution, you start with the last column, last non-zero column. This non-zero column, not column, sorry, my bad, last non-zero row. This non-zero row is telling you that we have X, Y, Z. So this is X column, this is Y column, and this is Z column. So it's telling you Z equals 1. Now the second column, second row is telling you Y minus 3 half Z equals 0. So we get, let me do it here. We have Y equals positive 3 half Z, but you already know if Z is 1. So Y equals 3 half times 1, which is 3 half. So Z equals 1, Y is 3 half. Now the first information, the first row is telling you X minus 2Z equals negative 2. So you have X equals 2Z minus 2, but you already know if Z is 1, so X equals 2 minus 2, so X equals 0. So the solution we get is X equals 0, Y equals 3 half, and Z equals 1. So we have a unique solution. Means every variable has only one number. Means the three lines you have, they're intersecting at one point. And let me check the answer. 0, 3 have 1, 0, 3 have 1. Yep, our answer is correct. So it took a while. It took 25 minutes because we did it slowly. But in your case, the first time it will be long, and then the more you practice, the less time you're going to get. And let me also warn you, all this side math we did here, if you make one mistake in this side math, you're going to get everything wrong. So be very careful when you do this math. And you definitely need to write down all these operations. Which operations you used. Come on. Which operation you used to get rid of each number. You need to write all of this down. Okay. So with this, we are done with 1.2. So you have homework 2 So 1 to F, 3A, 4A to F. I think these are something just converting into or figuring out what type of solutions you have. So probably these are not rational form or reduced rational form. Just figuring out what type of solution you have. And if you have infinite or any solution, what are those solutions? And then these are 3 real bad questions. Next week, Monday midnight, you have 1 week to do. For this problem, will you give like a card for credit? Are you talking about the exam or the homework? Exam. Exam has no carving. I'm going to give extra credit, but not carving. I actually showed my previous exam to the department, our coordinator, and I asked them, my students are asking me to carve their exam. Should I carve? And he said, no way. Your exam is baby exam, like too easy. So instructors supposed to carve exams which are challenging. For easy exams, no carving. And my exams are easy. Like I baby you guys a lot. Nope, no carving because my class is easy. Trust me. Like all the exams, when you see, you'll see like all the questions are from the review sheet. So as long as you study the review sheet, you're fine. Man, go ahead.
I have a question on the exercise we just did, like the assignment we just did. For the second column, first row, do we have like to modify it, or we can just leave it like that with the -2?
You can leave it and then you're going to do back substitution to find the answer, find the solution.
Oh, okay. So we can just leave it like that and after for the solution.
So when you
Okay.
leave it like this is actually raw echelon form. Raw echelon form. Anytime you need to do back substitution, it means you have your matrix in raw echelon form. When you have reduced raw echelon form, no back substitution is needed. But I'm too lazy. So if you feel lazy, you can just use raw echelon form.
Okay. Thank you.
No problem. Rakmanjan, you're taking 21 credit? Are you crazy? Wow. That's a lot. So, yeah. As long as you understand what you do in class, you'll be fine. And also, you need to practice so that the thing you understand in class really get into your head. Okay. So, try to enjoy your homework, even though it's a lot, but I can actually put some extra credit here. So I'll give you some extra credit since these are extra credit. These are a little bit tough. So once you do, like if you do them correctly, at least if your steps are correct and your math may not be correct, but at least you know what you're doing, then you'll be fine. Okay. So besides your 10 points, if you really do everything correctly, I'm going to give you how many more points? 3 more points extra for doing everything correctly. And if you don't do everything correctly, as long as you have all the steps correct and show all the steps, not cheated or not copied from AI or Google or anywhere else, then you're going to get full credit. No problem. So remember, its due date is next week, Monday. What date is next week, Monday? 9. Question, go ahead. Do 2/9/26. Oh, and you can only submit one file. So make sure you convert all of the pictures into one PDF file. I didn't make them available yet. I'm going to do it after class today. Not 1, 2, 3 extra credit. Like if you do all these questions correctly, then I'll be very happy for your hard work, and I'm going to give you 13 points instead of 10 points. And you're going to get 10 points as long as you do everything with correct steps. Your math may not be 100% correct, but as long as you showed all the steps and all those operations and did everything like what you're supposed to do, if you do them, then you're going to get you 10 points. Okay. Any question, comments, concern, complaint, anything? No. Now, did you guys ever realize that anytime you have any word start with Q in English, it's followed by a number, followed by another letter? Which letter you always have next to the Q? Good job, you. I actually never realized that until someone pointed that out. And then I realized, wow, question has QU. Queen has QU. Quiet has QU. Like every Q word has a U next to Q. It's so weird. And it's so fascinating. Like, wow. We know so many things, but we never realize. True. Okay, so we are done with 1.2. Now we are going to do 1.3. To be honest, I think 1.3 should have been the first section, because 1.3 has all the information about matrices, which you're supposed to know before you do 1.1 and 1.2. I don't know why they have this weird arrangement, but 1.3 is much easier than 1.2. So any question from anyone before we start 1.2? Any comments? Concern? Nothing? So 1.3, matrix arithmetic. A matrix is a rectangular area of numbers written within brackets, denoted by an uppercase letter. So every matrix, the name of the matrix is actually written with uppercase letter. You're never going to see a lowercase letter and then a matrix. And then every number you have or every variable you have in your matrix, we call them element. For example, here, 1, 3, 2, all of these are elements. Now, this, if you go from left to the right, the horizontal direction, we call them row, and the vertical direction, we call them column. So this matrix A has 3 rows because we have 3 horizontal entries, and we have 3 columns because we have 3 vertical entries. B has 2 rows and 2 columns. On the last example, we have 3 rows and 3 columns. So rows run from left to right, and columns runs from up and down. When we write the dimension of the matrix, means how many elements we have, we always have to indicate the row first and then the column. So for example, here, we have 2 rows and 2 columns. So we indicate its dimension as 2 by 2. and the by is indicated by X or multiplication. This is not 2 times 2. We call it 2 by 2. So here we have 3 by 3. This is called size of the matrix or the dimension of the matrix. It is important to note that the number of rows is always given first in the dimension. A matrix with n rows and n columns means if you have same number of rows and columns, we call them square matrix. So if you have a 2 by 2 matrix, it's a square matrix. If you have 3 rows and 3 columns, we call them square matrix. If you have 4 rows and 4 columns, we call them square matrix. So if your row and column are the same, we call them square matrix. And if your matrix has only 1 row, we call them row vector. If it has only 1 column, we call them column vector. So it's a matrix, but since it has only one thing, so we call them vector, not a matrix. So row matrix, instead of calling row matrix, we call them row vector, and column matrix, we call them column vector. Even if you call them matrix, it's not wrong, it just sound weird. So for example, let's say we have a matrix with 2 rows. So we have 2 rows and we have 1, 2, 3 columns. So if anyone asks you what's the dimension of your matrix, we call them, it's 2 by 3. So it's 2 times 3, that times is called by. Now in this 2 by 3 matrix, we have, let me erase this. We have 2 column vectors, so 2 row vectors. This is 1 row vector and this is another row vector. So we have 2 row vectors. For row vectors, usually we indicate with an arrow on the top of our vector. It means it's a vector. For column, we don't have to do that. So this matrix has 1 column, 2 column, 3 column. Each one of them, we can call them column vector. So for vector, we can use lowercase, but for the real matrix, we have to use uppercase. So we have column vector. The first one is 3, -1. The second one is 2, 8. And the third one is 5, 4. Since these are vectors, so we can use lowercase, uppercase, anything. But for the real matrix, we're supposed to use uppercase only. Now the position of the element in a matrix is given by the row and column containing that element. For example, let's say we have a matrix A, 1, 2, 3, 4. Now, if someone is asking you, what's the position for 2 here? So when you give them the position, you always have to write the row first and then column. So you're going to say our 2, the position for 2 is it's in row 2 and column, so it's in row 1. So this is our first row. It's in row 1 and column 2. So instead of writing R and C, we simply say it's 1, 2. It's the position 1, 2. So we use smaller case letter for position or for vector, and then a subscript for row and column. The first one is the row and the second one is the column. So if you want to know what's the position for 4, it's in the second row, second column. So the position for 4 is 2, 2. It means second row, second column. So you always have to start with row, in which row your number is, and then column, in which row your column is. So A11, we don't call them A11. It's A11. So you have to indicate each number individually. A12, don't call them A12. it's weird. It's 1, 2 means 1 row, 2 column. So first row, second column. 821, that's 21. It means row 2, column 1. Look at row 2, column 1. The number you have in there is 3. So that's how we indicate the position of anything, any element in a matrix. Now we have 2 types of diagonal. One is the correct diagonal, one is the wrong diagonal. The correct diagonal always goes downward when you walk from left to right. So this is your left. If you move from left to the right, you have to go downward. This is the correct diagonal. We call them principal diagonal. And principal diagonal has all the elements with double numbers. For example, A11, A22, A33, A44. So principal diagonal has the row and column same. If you observe, if you go other way around, we don't have that double number. For example, here, let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9. The position for this one is first row, third column. This position is second row, second column. This one is third row, first column. If you look at all the position, they are not double numbers. Only this one is double numbers. So this cannot be your diagonal. This is the wrong diagonal. The correct diagonal has to have the same number repeated. Okay? So you call them principal diagonal. And then some properties. 2 matrices have the same size if and only if they have the same dimension. So let's say we have matrix A, 1, 2, 3, 4. And let's say we have matrix B, 4, 5, 6, 7. 2 matrices have the same size. They have same size if they're the same dimension. So dimension for A, we have 2 row, 2 column. So this is a 2 by 2 matrix. B has also 2 rows, 2 columns. So this is a 2 by 2 matrix. So it's a matrix A and matrix B, they have the same size. Why? Because they have the same number of row and same number of columns. So same size means their dimension has to be same. 2 matrices of the same size are equal if and only if their corresponding entries are equal. So you have same size means either 2 by 2, 2 by 1, 3 by 3, like 2 matrix, they are same size. And if that same size matrix has the same elements within them, then we call them they're equal. Okay? So in order to have the same equal matrices, you have to have all the elements same. For example, here, matrix A has size 2 row, 3 column. So the size of A is 2 by 3. Matrix B has also 2 rows and 3 columns. So its size is 2 by 3. So they have same size. Not only same size, they also have to the same elements. So the first column is 1, 2, 3, 1, 2, 3. They matched. Second, not column, sorry, row. The second row is 4, 5, 6, 4, 5, 6, they match. So if you have the exact same elements in both matrices, then the 2 matrices are equal. Basically, you are replicating your matrix. And then we have 2 matrices of the same size may be added by adding their corresponding entries. So anytime you add or subtract 2 matrices, then you have to have their size same. 2 different size matrix cannot be added or subtracted. Okay, so matrix addition, subtraction requires only one condition. They have to have same number of rows and same number of columns. Their size have to be same. And with this, let's stop here. In our next class, Wednesday, we are going to do few addition, subtraction, and then few more properties. Okay. So this section is a fun section. And you are going to, let's see, we'll be able to finish it tomorrow in next class. Matrix multiplication, 2 by 2, 3 by 3, transpose. Most likely no. So if you can't finish, never mind. You already have a hard homework for next week. Never mind. We're going to finish it. This homework will be next week. So you have enough time. For now, concentrate on 1.2 homework. Okay. So do your 1.2 homework, and I posted these slides already. So if you want to try them before our next class, that would be great. If you want to read them, go ahead, read. And if you have the book, the PDF version, you can read the book also. Okay. So any question, comments, concern, anything before we leave? Nothing? Thank you. Thank you, everyone. Thank you so much. And I'll let you know tomorrow night whether we have Wednesday class in person or online. Okay. Thank you so much for your kind words, guys. Bye. Enjoy your homework. Thank you, Rahmanjan, for not minding to be online. Okay, bye-bye.